Good afternoon, and welcome to everyone attending today's webinar entitled When Testing Goes Green, It Is More Than Just a Pass Test. My name is John Brennan. The following presentation slides are aimed at anyone within the organisation. During today's presentation, we will look at the following areas: the future of software testing, testing realities, environmental impact, a real-world example, revised testing approach, evolving roles and responsibilities, and finishing off with reasons to go green. As we're all aware, the testing industry and associated processes evolve in reaction to a variety of factors, namely market sector changes such as regulatory body changes and mandated audit change, government and political change in the company's home country, Europe, or even worldwide, business environment changes such as those witnessed by the credit crunch, which has imposed strict budget constraints on a wide variety of project initiatives. In some cases, organisations are reviewing the testing methodology in place and looking at alternatives, or in some cases adopting at the very least some sort of framework, such as ISEB, ISTQB, etc. There are other contributing factors, of course, that impact testing services. However, those mentioned certainly play a pivotal role. Now, from a testing perspective, what is it that we are actually looking to achieve? Well, we are looking at reducing risk to the business, verifying that the delivered system or product meets the needs of the business and achieves what was set out in the original requirement specification. We are also looking to gain confidence in the proposed system or product, and of course to unearth defects before go live. However, what about global environmental considerations? In many testing projects, development lifecycle milestones and associated toll gates are planned at the project outset. As time goes on, concerns over the legitimacy of the original requirements, the understanding of those requirements, the development phases, and even IT environment delays ultimately lead to testing being squeezed. This is particularly true in regulatory-driven projects. This presents a number of concerns to the functional and non-functional risks to the project, such as those mentioned in the slide. For example, security concerns, functionality failure, performance and load issues, to name but a few. In some instances, project go-live dates can move, particularly when it is clear that the expected deliverable is still far from ready or even fit for purpose. This, however, presents its own challenges, such as loss of competitive advantage through missed market opportunity. Testing projects then begin to stack up, and parallel testing results in increased IT infrastructure resources being required. As a consequence, ineffective and inefficient testing results in resource wastage and ultimately global impact. I'll just pause here for a second as I've got a question in which is pertinent to this slide. In light of recent airline, travel and banking events, how do you see testing and timelines changing, and how quickly will this be seen? Well, I think from a financial services perspective, the collapse of Lehman Brothers and the merger between HBOS and Lloyds TSB will certainly see some enforced testing projects. The investment banking industry is so intertwined that the remaining banks in this sector will be forced to implement change quickly to minimise impact on themselves, whilst the HBOS and Lloyds TSB, we will now see some massive migration projects to force synergies between the two groups. The airline industry may not be impacted greatly from a testing perspective. However, it is clear that all organisations will need to streamline their businesses in all areas. I hope that accurately answers that question. I'll move on now. Let's now have a look at some examples of the impact the previously mentioned problems can now have on the environment. During a large testing program, a large number of client machines will typically be used to develop and test expected deliverable. For example, 1,000 PCs running 24/7 without energy-saving modes activated equates to as much as £70,000 worth of electricity in a year, according to Global Action Plan. Gartner estimate that PCs and monitors account for nearly 40% of global IT carbon emissions, nearly double that of the data centre. Each year, enterprises waste nearly $4 billion powering devices that are not even in use. Performance testing will play an even more pivotal role, highlighting packet sizes and how much traffic makes its way across local or wide area networks. Local and remote caching plays a critical role here to ensure that performance is optimised, which brings with it an improved end-user experience. This, however, also brings about energy and ultimately environmental savings. From a data center perspective, 50% of the energy costs is used to power the machinery, with energy costs expected to exceed the acquisition cost. The remaining 50% of the energy costs are then attributable to the air conditioning and UPS. In the UK, we utilise energy in the region of 1.15 billion kilowatt hours per year to power IT equipment, whereas in the States this equates to an excess of 50 billion kilowatt hours, or 1.5% of the total US electricity consumption, equivalent to the consumption used by approximately 5.8 million American households. Data storage is also growing at an alarming rate, leading to vast infrastructure requirements. It is estimated that 35% of all application data is duplicated, according to Forrester. Therefore, it is vitally important that we understand what technology is required to support our project commitments and testing phases, and then direct resources accordingly. There are technical solutions to help reduce the environmental impact at the data center. Multi-core processing, which can increase 64-bit application performance, reduces IT cooling and energy use, all while increasing system utilization through application consolidation. Some systems may be I/O, CPU, or even memory intensive, and virtualization can aid in this regard. The objective, however, is to understand which virtual workloads can be combined on physical systems without causing resource constraints, with gains estimated at 70 to 80%, with return on investment in 3 to 6 months. Again, virtualization offers reduced energy consumption and wastage through reduced hardware requirement and greater utilization of what is available. Either approach, or any other technical solution, will dictate the chosen testing strategy, as each solution brings with it its own challenges. It is therefore important to have appropriately skilled testing professionals to support the chosen solution. Finally, it is important to remember that the IT industry is widely recognised as contributing 3 to 4% of the world's carbon emissions, greater than that of the much maligned airline industry. The following details relate to a real client experience. The development life cycle is chaotic, with diluted lines of responsibility and a number of grey areas. Whilst a certain level of testing lifecycle has been adopted for UAT and regression, there is still little priority for system or unit testing, which is effectively what the UAT phase in this example finds itself responsible for, with regression test packs being executed shortly afterwards, or in many cases in parallel. Defects found could easily have been avoided using static techniques,